Hi, Falcons! As you know, I am not here today on Monday. And so for today, we are going to watch this ed puzzle in class. We are going to go over graphing quadratic functions in standard form, which we've actually already gone over once this year. So this is going to be a really great review for you today. Now, as you see in this packet, there are 7 example problems. We are going to do 3 of them in class together through this ed puzzle. And then the remaining 4 are going to be your homework, which you will have access to the key at the end of class to make sure that you're following along correctly. So let's go ahead and get started. When we graph a quadratic in standard form, we are using the form ax squared plus bx plus c, where our a value is right here as the coefficient in front of your x squared. We have our b value in the middle, and then our c value is our constant, or otherwise known as our y-intercept in the graph. With our graph, a few key concepts that we're going to be talking about today is our axis of symmetry. We are also going to be talking about our vertex. We're going to be including x and y intercepts, so we are going to have to take this equation in standard form and solve for x. And then also we are going to practice sketching. So this video has a lot of good resources for us to really make sure that we go back, circle back, and understand graphing in standard form. So first, let's start with example number 1. We have y equals x squared minus 5x plus 4. Now, first off, because we see that we only have x squared out to begin with, that means our leading coefficient is just 1, positive 1. So that means that our parabola is going to be concave up. It is going to be this U-shaped figure. Now, because that a value is just 1, that means that there is no stretch or shrink or compression or whatever you want to call it that your teacher uses. There is none of that. So we can go ahead and circle neither. So that means that when we go ahead and start sketching that U-shaped figure, our x value, we're going to be able to just square it each time. So from the vertex, we can go out 1 and up 1. From the vertex, we can go out 2 units and up 4, and then out 3 and up 9, and so on and so forth. So let's go ahead and begin. When we have this in standard form, it is always best for us to go ahead and just solve for x and find the x-intercepts first. Remember, our x-intercept are the same as our solutions. When we solve for our solutions, we can go ahead and set the equation equal to 0. So 0 is equal to x squared minus 5x plus 4. Now, it is definitely up to you on which method you would like to use to solve. For example, we probably already can tell that we cannot use the square root method because we do have a b value. However, it is up to you if you'd like to factor this or if you'd like to use the quadratic formula. If you use the quadratic formula, it might take you a little bit longer to get to your solution, but you still should be able to get to the same conclusion as we do if we factor it. So because the number 4 can be factored into 1 and 4, we know that 1 and 4 somehow make 5. 5 is negative, so if we use negative 1 times negative 4, not only does that create a positive value, but if we add negative 1 and negative 4, it creates a negative 5. So our two factors are x minus 1 and x minus 4. So now that we have that, we can go ahead and set each factor equal to 0. And we can solve for x. We'll add 1 to both sides. We get that x is equal to 1. We can add 4 to both sides. We get that x is equal to 4. So therefore, our two x-intercepts here, they're just solutions, x equals. When we write our final answer for our x-intercepts, we do want to write them as ordered pairs, so 1, 0, and 4, 0. And we can go ahead and plot those points right over here. I know my face is in the way a little bit, so I'll move myself down here. So we can go ahead. 1, 0 is right there on the right side of the coordinate of the origin. And then 4, 0 is also on the right side, and that is right about here. So now that we have our x-intercepts, we can go ahead and work together to find our axis of symmetry. We can go ahead and work together to find our vertex. However, because our equation is in standard form, there is another question that we can answer right away that doesn't involve very much work at all. And in fact, that is our y-intercept. Remember, your y-intercept is always going to be your c value, and that is only going to be the case in standard form. Now, because we are given an equation in standard form, our c value is 4. So therefore, our y-intercept is 0, 4. And in fact, we can go ahead and we can just plot that right away. So 0, 4 is right up here. Okay. So now we have two pieces left, our axis of symmetry and our vertex. Because our vertex relies on our axis of symmetry, that is going to be the very first problem that we do together. We'll do that axis of symmetry problem, and then we'll use the axis of symmetry to go ahead and find the vertex. So our axis of symmetry is always the equation of the line where x is equal to the opposite of b over 2 times a. If you're going back and doing those last 4 problems by yourself for homework and you forget what the axis of symmetry comes from, go ahead and turn back to this very first page of your notes, and it is given to you in that book definition. So we can show our work maybe down over here. We know that we use that acronym AOS for axis of symmetry. So we can say that x is equal to the opposite of b is positive 5 over 2 times a, which is just 1. So therefore, x is equal to 5 halves, which when we're thinking of graphing, it might be easier to think of this as a decimal to kind of see like where does that line, that vertical line kind of line up. We know that it's not going to be a whole number, but if you go ahead and take your calculator and we take 5 divided by 2, we see that that's 2.5. So our axis of symmetry is going to be the equation of line x equals 2.5, which makes sense because if we think about spatially the two x-intercepts, there is 1, 2, 3 units in between, and we want to cut that space in half. Well, what is half of 3? It's 1.5. So we would go 1.5 in and 1.5 in from the other direction, which gives you that value of 2.5. So we can go ahead and draw our vertical dashed line right down the middle. Just like that. So now that we have our axis of symmetry as 2.5, we can use that x value and substitute it in anytime we see x in the equation. So for our vertex, we can say 2.5 squared minus 5 times 2.5 plus 4. So our y value is equal to, because remember, we already know what x is, so we are looking for y. So we can go ahead and say, I just want to make sure you guys can see this on the screen, 2.5 squared minus 5 times 2.5 plus 4, and that gives us negative 2.25. So if we go to this axis of symmetry right here, when x is 2.5, we go all the way down to negative 2 and just a little bit further, and we plot that vertex right here. Now, because our parabola is always symmetrical, if we know that 0, 4 is 2.5 units away from our vertex to the left, then we can plot that mirroring point, 2.5 units to the right, 4, all the way right here. And now we have enough points for us to be able to sketch this parabola. Remember, it doesn't have to be perfect in any means, but it definitely should not be pointy at the bottom, and it should not look like a V. It definitely should look like a U-shaped figure. And if I zoom out a little bit of our first example, this is the parabola to y equals x squared minus 5x plus 4. Now, if you really have some extra time and if you really want to make sure that you're doing this correctly, You can always graph this in your calculator. So x squared minus 5x plus 4. If you hit graph, if you take a look at that, this does look pretty similar to exactly what we're doing. You have an x-intercept at 1. You have an x-intercept at 4. You have a vertex that's about negative 2.25 on your screen visually. So we know that we've done this correctly. Nice job. So let's go ahead. Let's turn our page. The next two examples, like I said, we'll do together in this video. However, the last remaining 4, so pages 3, numbers 4 and 5, and then page 4, numbers 6 and 7, are going to be your homework for tonight. So if we go ahead and get started with this first example, we can take a look at number 2. Number 2 is the equation or the function y equals negative x squared minus 4x plus 5. So first off, is it concave up or concave down? Well, because we see this negative out in front, we know our a value is negative 1. So therefore, we know that this parabola is concave down. Now, because our coefficient outside of x squared is still just 1, whether it's positive or negative, that means that there is not going to be any type of vertical stretch or compression. Now, in terms of the order of the way these questions are asked, a few of these are going to determine work, and one of these is not. If you remember from that first page, that very first example we just did, your C value is always your y-intercept. So because our C value is 5 in this case, our y-intercept is always going to be 0, 5. And once we know that point, we can go ahead and just plot that right away. 0, 5, which is right there. Now, it is up to you if you'd like to do your axis of symmetry and then your vertex, or if you'd like to do your x-intercepts and then your axis of symmetry and your vertex. Since we did our x-intercepts first last time, maybe we want to do our axis of symmetry first. So let's go ahead and let's take a look at that. For our axis of symmetry, you'll need a b value and you need your a value, because our axis of symmetry is the equation of the line where x equals the opposite of b over 2 times a. So in this case, the opposite of b is positive 4 over 2 times a, which is negative 1. So therefore, our axis of symmetry is 4 over negative 2, which reduces down to negative 2. So our axis of symmetry is the equation of the line x equals negative 2. Now, sometimes in the past, many of us have forgotten to write this as an equation of a line, but it's really, really important that we do write this as x equals. So x equals negative 2. And then we can go ahead and we can just plot this vertical line. So we can go ahead, draw that dashed line where x equals negative 2. And voila, we're almost done. So now that we know our axis of symmetry, the thing that directly falls right underneath it, because it's dependent on our axis of symmetry, is our vertex. So our vertex is going to be where we take that negative 2 value and we substitute it in for x. So first off, the negative out in front will always stay negative. It does not affect the substitution at all quite yet. So we leave that out in front, and in parentheses, we put negative 2 squared minus 4 times negative 2 plus 5. Now, your calculator will do the order of operations for you, but I just want to remind you that this negative 4 times negative 2 will become positive, and this negative 2 squared also will become positive, because a negative number times a negative number is a positive value. However, this negative 1 then multiplies to that value. So we still are going to possibly be dealing with some type of negative number. We just have to wait and find out as to how this adds up. So let's take a look. In our calculator, move that up so you guys can see. We have -1 out in front, or just a negative, parentheses, -2 squared, side arrow over, -4 times -2 plus 5. And we get 9 as our value. So our y value is equal to 9, which means our vertex is -2, 9. -2, 9 is right up here. Now, that makes sense because if our parabola is concave down, we want that mountaintop up top. We want that peak. We want to be climbing the mountain and get to the top and then work our way back down. So we definitely want a value that is going to be higher up so that way everything kind of falls proportionally off to the sides on it. So now for your x-intercept, it is completely up to you which method you'd like to use for solving. If you would like to factor it, keep in mind that whenever we factor, we really don't want to deal with a negative coefficient. So we are going to have to take out a GCF of -1. Now, if you'd like to use the quadratic formula because maybe taking a GCF of -1 out might scare us, or maybe we're just not comfortable with that quite yet, then go ahead and use the quadratic formula. Your A value is going to be -1. Now, because we factored on that last example, let's use the quadratic formula. Why not, right? So let's go ahead and we can say that x is equal to the opposite of b, which is going to be +4, plus or minus the square root of b squared, minus 4 times a, which is -1, times c, which is 5, all over 2 times -1, because a is negative. Okay, so now when we keep going, we have 4 plus or minus. Well, -4 squared is 16. 16 plus 4 is 20. Or I'm sorry, order of operations. Oh my goodness. -4 times -1 is +4. +4 times 5 is 20. So 16 and 20 make 36. If you'd like to double check it in your calculator, that's never a bad idea. -4 squared minus 4 times -1 times 5, which does give us 36. So 4 plus or minus the square root of 36 all over -2, which we know the square root of 36 is 6. So this turns into 4 plus or minus 6 over -2. So x is either equal to the positive of that or x is equal to the negative of that in terms of that plus or minus. So x is equal to 4 plus 6 divided by -2. And x is also equal to 4 minus 6 divided by -2. Well, 4 plus 6 is 10. 10 divided by -2 is -5. So our first x-intercept is -5, 0. We can plot that point right there. And then our second x-intercept is 4 minus 6, which is -2. -2 divided by -2 is +1. So our other x-intercept is right there at +1. Now, just like we said in that first example, a parabola is always a mirroring image. So from our axis of symmetry, your y-intercept is 2 units away to the right. So we can totally add another point on this parabola that is in the exact same spot for y, so at a height of 5, but is 2 units to the left of the axis of symmetry. And now if you notice, we have our vertex, the one lone soldier up at the top, mirroring points, and that's enough points to really get a good feel for what this parabola looks like. We know it's concave down, so we can sketch one side, make it curvy, not a V-shaped figure on the other side, and then we want to make sure that we draw our arrows down because this is concave down, and a parabola does extend for forever in terms of domain. And that is our second example. So now our very last example that we're going to be doing in class, if you take a look at it, we do have an a value finally. So it's going to affect some of our answers. Now, because our a value is 0.5, sometimes dealing with a decimal can be tricky, but I promise you it's not going to be that bad for this example. So first off, we notice that our a value is 0.5, but it's still positive. So that means that our parabola is going to be concave up. Now, because our a value is 0.5, something is going to happen to our parabola, and let's take a look on our calculator. So first off, let's just graph the parent function, y equals x squared. If we graph it, it has one x-intercept at the origin. It's very proportional on either side. That is the parent function, and we always compare it to what this one looks like. Now, if we take a look at the parabola that we're given, we can plot that in y2. And really, in terms of compression or stretch, we just care about the a value. So we could just graph 0.5x squared. We don't even really have to graph the entire function. And let's go ahead and hit graph. That will be our new line that appears with it. And if you look, it looks a little bit wider. Parabolas that are wider than the parent function are compressed. Think of an accordion. If you have an accordion, then it plays up and down just like this. If someone were to go and went smush, right, it compresses down and the sides come out of it. So same thing with a parabola. If you're like bouncing on that parabola, every time you compress it, the outsides are going to get wider. So this is a vertical compression. All right, now we have a few options. We can do the axis of symmetry first. We can use the x-intercepts and find those first. We do have a c value, so we could do the y-intercept. The world is your oyster, right? You have so many options that you can choose to do first. Because our c value is pretty much already always given to us in the standard form, let's just write that down. So number 2 is our c value. So therefore, our y-intercept is 0, 2. And we can go ahead and plot that right away, just like this. 0, 2. Okay, last time we went ahead and did the axis of symmetry first and then the vertex. For this example, let's do the x-intercepts first. So our x-intercepts is that we do need to find the solutions and then turn them into ordered pairs. However, if you've noticed, because our a value is 0.5, it's really hard to try and figure out what factors, what two numbers multiply to 2, but then we're dealing with this 0.5. So really, when in doubt, let's just use the quadratic formula. So the opposite of b is -2 plus or minus the square root of b squared, so that's 2 squared, minus 4 times a, which is 0.5, times c, which is +2, all over 2 times a, which is 0.5. And voila. Now, if we keep going, we can go ahead and evaluate underneath that square root. So 2 squared minus 4 times 0.5 times 2 is 0. Oh my gosh, it's 0. That's awesome. So now we have -2 plus or minus the square root of 0 all over 2 times 0.5. I think we already know that 2 times a half is just going to be 1, right? We're just cutting 2 in half. But if you didn't know that, that's okay. And now we know that the square root of 0 is just 0. And we know that if we add or subtract anything to 0, it's just going to be itself. So really, -2 over 1, or just -2, is the only x value, and I'll move this camera, I'm sorry, is the only x value that we have. That's awesome. We have one solution. So our x-intercept is -2, 0, and that lies right there. So now we can go ahead, we can use the axis of symmetry to find the vertex. But first, before we do that, we have to find the axis of symmetry. So our axis of symmetry is the opposite of b over 2 times a. which is negative 2 over 2 times 0.5, which is negative 2 over 1, which is just negative 2. Now, when you only have one solution, your axis of symmetry will always be the x value of that solution. Because if there's only one point at the vertex that's your x-intercept, cutting it in half just directly cuts through that point. So our axis of symmetry is where x is equal to negative 2. And some of you guys might have already made that connection just by when we've done this in the past. But if not, just remember that whenever we do have one solution, that one solution is not only our vertex, but it's also our x-intercept, which means both of those share that axis of symmetry, which we can see on that dashed line. Now, our vertex, as you guys can kind of guess, if we substitute negative 2 in for x, because it's already on the x-axis, and because there's no point lower than that, I think we're already going to know that our vertex is just the x-intercept, but let's just double check. So our vertex is 0.5 times negative 2 squared plus 2 times negative 2 plus 2. And if we plug that into our calculator, boom, we get 0, and that works. So our vertex is negative 2 comma 0. It's already plotted. Again, we do need like a few more points to be able to sketch a good picture of this graph. So like you see right here, your y-intercept is 2 units to the right away from the axis of symmetry. So in order to create a mirroring point, we could just go 2 units to the left. We keep our y value the same, and the other mirroring point is at negative 4 comma 2. And now we can go ahead and we can just sketch this parabola where we only have one solution. So with that, I hope you guys have an awesome, awesome Monday. I apologize that I'm not here today. As soon as I get back, you guys will be able to get your tests back that we took on Friday. I do miss you guys, and I hope you had an awesome weekend. Just remember, this week is short. We only are in school for 4 days, and so we do not have any school on Friday. So just to reiterate, and I'm sure the sub will remind you, your homework for tonight is numbers 4, numbers 5, number 6, and number 7. And just a friendly reminder, we have done this before. So I know sometimes it's a little bit tricky to go back and review past material, but you guys are totally capable of doing this. Tomorrow we're going to go ahead and start graphing in intercept form and factored form, which I think you guys might really like. So other than that, I will see you guys all later. Have an awesome Monday night, and we'll talk soon. Goodbye.